morning guys, so welcome again to my video and for this video I will going to summarize this chapter. So let's start. Chapter 7 IP address summary. Addressing is critical function of network layer protocols. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol version 4 IPv4 and Ethernet Protocol version 6 IPv6 provide hierarchically addressing for packets that carry data. Designing, implementing, and managing an effective IP address plan ensure that networks can operate effectively and efficiently. This chapter examines in detail structure of IP addresses and their application to their construction and testing IP networks and subnetworks. IP addresses are hierarchically with networks, subnetwork, and host portion. An IP address can represent a complete network of specific hosts or broadcast address of network. Understanding binary notation is important when determining if two hosts are the same network. These bits within the network portion of the IP address must be identically for all devices that reside in the same network. The subnet mix or prefix is used to determine the network portion of an IP address. IP addresses can be assigned either statically or dynamically. DHCP enables the automatic assignment of addressing information such as IP address, subnet mask, default gateway, and other configuration information. IPv4 hosts can be communicated one of three different ways: unicast, broadcast, or multicast. Also, blocks of addressing that are used in networks that require limited or no internet access are called private net addresses. The private IP4 addresses blocks as 10.00.0/8, 172.16.00/12, and 192.168.0.0/60. Then IPv address bits are 30. IPv address is compressed for octets of binary digits, each containing 8 bits, resulting in 32 bits address. IPv4 address is divided into two parts: a network portion to identify the specific network on which a host resides and host portion to identify specific hosts in the network. A subnet mask is used to identify the length of each portion. The /24 show that the network or bits 24 show that the network's address 172.17.4.0. The broadcast address for this network would be 172.17.4.255. Usable host addresses for this network are 172.17.4.1 through 172.17.4.254. With IPv4 addresses, a subnet mask is also necessary. A subnet mask is a special type of IPv4 address that configured with IP address determines the subnet of each device in a member. A directory broadcasts messages to send to all hosts, specifically network. It is useful for sending broadcasts to all hosts on non-local network. A multicast message is a message to send selected group of hosts that are part of subscribing multicast network. A limited broadcast is used for communication that is limited to the host on the local network. A unicast message is a message to send from one host to another. Broadcast message consists of single packets that are sent to all hosts on a network segment. This type of messages are used to request IPv4 addresses and map up upper layer addresses to lower layer addresses. A multicast transmission is a single packet sent to a group of hosts and is used by routing protocols such as OSPF and RIPv2 to exchange routers. The addresses range 224.0.0.0 to 224.0.0.255. It received for linked local addresses to reach multicast group or on a local network. There are three techniques to allow IPv4 and IPv6 to exist on a network. Dual stack allow IPv4 and IPv6 to coexist on the same network segment. Dual stack devices run both IPv4 and IPv6 protocol stack simultaneously. Tuning in is a method of transporting an IPv4 packet over an IPv4 network. This IPv6 packet is encapsulated inside the IPv4 packet, similar to the other types of data. Network address translation 64 NAT64 allows IPv6 enabled devices to communicate with IPv4 enabled device using translation techniques similar to NAT for IPv4. When IPv6 is enabled on any interface, the interface will automatically generate IPv6 linked local address. Multicast, anycast, and unicast are type of IPv6 addresses. There is no broadcast address in IPv6. Loopback and link local are specific types of unicast addresses. There are three elements that make up an IPv6 global unicast address. A global routing prefix, which is provided by an ISP, a subnet ID, which is determined by the organization, and an interface ID, which uniquely identifies the interface of a host. Stateless DHCP B6 allow clients to use ICMP-B6 router advertisement (RA) message to automatically assign IPv6 addresses to themselves, but then allow this client to contact a DHCP B6 server to obtain a conditional information such as the domain name address of the DNS server. SLAAC does not allow the client to obtain additional information through DHCP-B6. Stateful DHCP-B6 required that the client receive its interface address directly from DHCP-B6 server. RA messages, when combined with an EUI64 interface identifier, are used to automatically create an interface IPv6 addresses, are part of both SLAAC and stateless DHCP-B6. SLAA is used to ICMP-B6 message when dynamically assigning an IPv6 address to a host. DHCP-B6 are alternate method to assigning IPv6 addresses to hosts. ARPv6 does not exist. Neighbor Discovery Protocol or NDP provides the functionality of ARP for IPv6 network. UDP is Transport Layer Protocol used by DHCP-B6. A ping command provides feedback on the time between when an echo request was sent to remote host and when the echo reply was received. This can be measure of network performance. A successful ping also indicates that the destination host was reachable through the network. The purpose of ICMP messages is to provide feedback about issues that are related to the process of IP packets. ICMP-B6 sends a time-exceeded message if the router cannot forward an IPv6 packet because the packet expired. The router used a hook field to determine the packet that has expired and does not have a TTL field. To convert binary number to decimal equivalent, add the value of the position where any binary 1 is present. Link local addresses are assigned automatically by the OS environment and located in the block 169.254.0.0 bit 16. The private addresses range are 10.00 bits 8 and 172.16.00 bits 12 and 192.168.00 bits 16. Testnet addresses belong to the range of 192.0.2.0 bits 24. The addresses in the block 240.0.0.0 to 255.255.254 are reserved as experimental addresses. Loopback address belong to the block 124.00.08 bits. So thank you guys for watching. I hope you like this video and see you again in my next vlog. Bye bye!